In this lecture, we'll move beyond Python to talk about databases in SQL or SQL. We're going to discuss when you'd want to use a database. Why can't you just use pandas or other Python tools? We're going to talk a little bit about how to set up a database using PostgreSQL, which is perhaps the most common, open source, free database available. And we're going to explore some very simple queries. And then we'll look at how to integrate a database with Python and QGIS, a great open source GIS software package. This lecture is mainly going to be a taster. We're not going to do much SQL coding. Rather, I want to give you enough background so you'll know when you need to do this and then where to get started. And if you're already familiar with a lot of GIS work, this primer by Helen Mackenzie, I really recommend it as a guide to transitioning to SQL. One takeaway I want to leave you with: the best databases here are open source, and many GIS packages are open source. You shouldn't need to pay money for ArcGIS. But as long as most public agencies continue to think otherwise, ArcGIS is an important skill for planners, but for your own work, you don't necessarily need to be bound by this proprietary software. So why would you use a database? Well, in most cases you don't. Python in general and pandas, GeoPandas, are going to do an excellent job for your data science workflow. But sometimes they're not the best option. And here are some situations when you might want to consider a database. If your data set won't fit in memory, or if multiple users need concurrent access, or if you need to validate and maintain the integrity of the data, if you want to have what's called access controls or transactions. The transaction is if your computer crashes halfway through, your data is not going to be corrupted. Many planning agencies do have databases that are already hosted on the agency's server, for example, a permit database or GIS files. And some of these might be spatial databases, like with Esri's ArcGIS suite. So you might want to query these as part of your work, a database that's already set up by someone else. But you can also set up your own database, even on a laptop. Really what you need often is just an external hard drive if you're going to have a lot of data, which are pretty cheap. Of course, if you want someone else to access your database, you need to have a computer that's always on with a stable internet connection. Like an old computer in the corner of your office is often going to work pretty well for this. But the key takeaway here is that if you want to preserve and maintain your data, if it's permit issuance or rider surveys or asset inventories, this should not be an Excel file on someone's computer. What happens if they retire? Or what happens if their computer gets stolen? Or if someone inadvertently tries to help by correcting the data and introduce errors? What happens if there's multiple versions of this Excel file floating around computers? That's a data integrity nightmare. Databases are a great way to, for something that's long-lasting and is used by multiple people and is a permanent record of an agency's assets or data, a database is the way to go. So how do you set this up? Well, I highly recommend PostgreSQL, or Postgres for short. It's free, it's open source, it's cross-platform, it's well supported, it's updated, and it has really good spatial analysis capacities for the PostGIS extension. Now, most databases use SQL, structured query language. So if you learn Postgres, you'll be able to use pretty much any other database flavor with minimal issues, with minimal learning curve to convert. We're not going to install Postgres for this class, but if you feel inclined to experiment, this PostGIS site compiles clear instructions for multiple platforms. And again, you don't need a fancy computer to download and run this. But you can also run Postgres in the cloud. So Postgres organizes your data into databases. I have one database typically per research project. Schemas, these are like folders. And then tables. So each database table is like a pandas or a GeoPandas data frame. And how do you access the data? Well, there's a graphical interface which comes with Postgres, pgadmin. This runs in a web browser. You can also use a command line, PSQL, or you can use QGIS, which interfaces really nicely with Postgres databases, and that's one reason why I recommend it for spatial data. And then pandas is also able to access databases through some pandas function, the read SQL query, and the toSQL functions. So let's look at some basic SQL queries. So even if you don't set up your own database, it can be useful to know how to query this using SQL. The intuition is pretty similar to pandas, particularly with joins and group by functions. So we're going to work through some practical examples, but rather than setting up a database and querying it, we're going to query a pandas data frame using SQL, using this pandas SQL library. So we're going to use the same Ventura County collisions data from a couple of weeks ago. We can look at the data structure again. We've seen all this before. So I'm going to load in my 3 data frames. And then just for simplicity, I'm going to convert all the columns to lowercase. In Postgres, all column names are lowercase, and so this avoids problems if you start out that way. So let's look at our data frames. OK, so this is the same as we had before. So simpler SQL queries take the form like this. So you select a column, another column, maybe some more columns from table name, and your query ends with a semicolon. So if we want to get 2 columns from our collision data frame, collision date and officer ID, our query would look like this. And this is exactly the same as if we looked at the subset of these 2 columns from pandas. We're getting exactly the same output. We're just using PDSQL to use SQL syntax to query our pandas data frame. What if we only want to get a subset of rows? Well, we'd use the where condition. So this is what we saw before, but where this condition is true. So suppose we want to get the 2 columns where a pedestrian is involved. If we look back at our documentation, this is any value except A in this ped action column. So I'm going to do where ped action is not equal to A. So this is the same in pandas as where I just filter. Ped action is not equal to A. We get exactly the same. Other useful queries. Rather than a column name, star is going to give you all columns. Distinct is going to give you unique values. Limit is going to just give you a certain number of rows, like 10. Limit 10 will give you 10 rows. And count star is going to give the number of rows. So how many officers are responding to collisions in this data set? Well, the first 5 officer IDs are given here. And in pandas, unique is a good way to get this same information. See, we get the same officer IDs through this unique as we did with pandas SQL. Or we can look at the first 2 distinct officer IDs. So if we limit 2, we get the first 2. How many of them? Well, it looks like we have 176 officers that are responding to collisions in our data thread. So I'm going to ask you to pause the video here and write a SQL query to report the number of collisions that this first officer, 3386, was involved in. So how did I do this? Well, count star is going to give a number of rows. And then I'm just going to have a where condition, where officer ID is 3386. Looks like they were reporting or responding to 2 collisions. Another useful function in SQL is group by. And conceptually, this works the same way as group by in pandas. We're trying to group by a certain field. We're then splitting, we're aggregating, and we're combining to produce some summary statistics like means or standard deviations or counts. So if we want to group by the number of collisions by jurisdiction, we can select a jurisdiction and the number of rows in our data set, and then we're going to call this column n from our collision data frame, and we're going to group by jurisdiction. So jurisdiction 5600 has 75 collisions, and so on. If we want to do this in pandas, we can just use the size. We see we can get exactly the same output. Then finally, we can join tables together. And normally, if we want to save disk space, we wouldn't create lots of tables that have all these join values. We'd do this on the fly. We'd recreate the joins exactly at the moment that we need them. But the join concepts, like inner joins, left joins, one-to-one joins, one-to-many joins, these are the same as we've talked about with pandas. So our query here, there's our triple quotes. This allows us to have a string that goes over multiple lines. And the line breaks here are just for ease of reading. Let's select everything from our collision data frame, doing a left join to our parties data frame. What are we going to join on? This is our join column. It's case ID. So we see that we have our collision columns, and then we have our parties column, like whether this party was inattentive and so on. There's also spatial operations that you can do in PostGIS. Supports all of those in GeoPandas and many more. We're not going to do this here because it's not well supported by Pandas SQL, but if you have a PostGIS database set up, then these spatial queries are very simple. For example, if you want to select all the parcels and find out what city they're in, select all the columns where this parcel geometry is intersecting the city's geometry. So this is basically doing a spatial join using intersects on these two geometry columns. Now, we could have done all of these operations that we've done this lecture just in basic pandas. So normally there's no reason to use pandas SQL. The point of doing this was to just demonstrate the SQL syntax so that if you have a database you need to access, you're familiar with how to write a SQL query. But the broader point here is Python rather, a great advantage of it, in particular compared to languages like R. Python is really well suited to gluing together different operations. A lot of technical and scientific software has what's called Python bindings. You can access their functionality from within Python. So you can query a database which is in the cloud or on an office computer or on your own computer using the scicop2 library. That's a binding between Python, allows you to access a database from Python. Statistical software. You can access more advanced statistical functions in R or in Stata using the rpy2 function for R. Stata has a similar Python bindings. If you're a Bayesian, then you can use stan. And PyStan is certainly what I use in some of my work that allows me to run stan functions from within Python. GIS software, QGIS, ArcGIS, they have Python libraries that are associated with them. And then some system level functions which we've seen, like copying files, opening a web browser. This is also something that you can call from within Python. So I'm going to stop there, but if you want to go further, I highly recommend the book PostGIS in Action. This is an excellent introduction to spatial databases in PostGIS and has some basic background on Postgres as well. But the takeaways I'll leave you with. Databases are certainly more complicated to set up and work with than Pandas data frame, but if you have a lot of data, lots of users, or you have requirements for data validation and integrity, you should be using a database. In a database, it is smart about when to do an operation on disk and how much memory it has available to actually do some operations in memory. So if you have data that don't fit in memory, you can deal with really, really, really large files with a Postgres database. SQL uses different syntax, but the conceptual framework is similar to querying a pandas data frame. We just saw that in this lecture. And then finally, think of Python as a glue that holds together your data collection and analyses processes together in a single set of code. I'm going to leave it there. I hope you've enjoyed this course. I hope you've got something useful out of it. Go forth and do some interesting and useful data science.